Quoc was one of the first members of Google Brain, and he's been consistently one of the real groundbreaking researchers in deep learning. So that includes some of the initial breakthroughs in computer vision before AlexNet, some of the first breakthroughs in sequence-to-sequence modeling, and he was one of the authors of the well-known neural machine translation paper recently. So really excited to have him here, and he's going to be talking about AutoML.
Hi, everyone. My name is Quoc Lee, and I'm a member of the Google Brain team. The Google Brain team, the mission of the Google Brain team is to advance the frontier of research in artificial intelligence and deep learning, and bring the research innovations to make lives better. Now, because of the second part of the mission, in the last few years, you've seen that Google Brain have developed a lot of tools for developers like TensorFlow and TPUs, so that we can bring some of our research innovations to the outside world. Now, also because of that part of the mission, in the last 3 years, I have been thinking very seriously about the following question: what is the bottleneck of the broad adoption of artificial intelligence in the outside world? How can we do better so that artificial intelligence and deep learning can be adopted more widely? Now, if you look more closely in a typical machine learning solution, you see 3 parts. First, you see a machine learning expertise, and then you see some data, and then some computation. Now, obviously, one of the 3 parts could be the bottleneck. So let's look into this pipeline more closely. So the first question is data the bottleneck? And my intuition is that the answer is no. And now, every business is embracing digitalization, and then we have the big data and the cloud make it possible and more easy for people to gather more data. And the second question is computation the bottleneck? Now, the answer is also no. AI computation is double every 3.5 months, and it increased 300,000 times since 2012, since the breakthrough of AlexNet. So it's even beat the Moore's law. And you can see this very interesting chart by OpenAI. Or is it? By OpenAI, where since AlexNet, can I go back? Yeah. Since AlexNet to AlphaGo 0, we have gained 300,000 times increase in compute. And part of the reason is that we develop more and more accelerators. And neural nets are very friendly to parallelism. You can train, even though every chip doesn't get faster, you can build more chips. And it becomes cheaper. And at Google, we build cloud TPUs, and a lot of researchers benefit from this a lot. Now, I concluded that machine learning expertise is the bottleneck of AI adoption. Machine learning expertise is very scarce resources. We only there are million of businesses, but we only have 22,000 available machine learning experts globally, and supply and demand gap is huge. And this sentiment is agreed by many experts. For example, Joshua Bengio, the professor in the University of Montreal, he also said in the New York Times the same thing. given this conclusion, we ask ourselves, what can we do better? And here, what we are proposing. So the standard machine learning solution, you have machine learning expertise plus data plus computation. And we want to develop a new solution where machine learning expertise will be mainly replaced by a new tool called AutoML. But we trade off the lack of knowledge in AutoML by a lot of computations. And we want to use 100x or 1,000 times more computation. So the advantage of AutoML is the following. Before, when you do traditional machine learning, you, on the left side, the number of machine learning applications will be scaled by the number of machine learning experts. So if you have the number of successful machine learning applications will be proportional to the number of experts that you get access to. Now, in the age of AutoML, my prediction is that the number of successful applications that you have will be proportional to the number to the computation that you have access to. So it become more like a pure computation game. Now, so what is automated machine learning? So basically, we started automated machine learning research at Google maybe around 3 years ago. And first is actually, is this an approach to accelerate research in machine learning? So so the first question that we're trying to ask is, can AutoML design a better model than machine learning expert? And then in trying to answer that question, we say, let's pick the hardest component that in a machine learning pipeline that everybody find that is so difficult to design. And we concluded that let's take a convolutional net, and then if we design a better convolutional net than the best expert in computer vision, then we say, well, that's success. And we just did just that. So we developed this framework called neural architecture search. So by the way, neural architecture search is a subset of AutoML. And just to trying to answer the following question, can you design a better architecture than an expert in computer vision? Now, we developed this framework as follows. So we have a controller, and the controller will basically generate a little program that specifies the configuration of the architecture of the neural net. You know, how many layers, what kind of connectivity, what type of layers, and then what kind of learning rate. And then that architecture will be executed at a child model. And one of it will be successful, and one of it will be very bad. And the successful network will inform the controller that maybe we should sample more and more networks looking like this to get better accuracy. So this loop will run 20,000 iterations in order to generate a good final architecture. And so maybe the better way to see in the picture is the following. You have a controller, which is one neural net. The neural net will basically train and evaluate models. And the feedback from the success or failure of each of the child model will inform the controller so that the controller will do better next time. So it's machine learning for machine learning. Now, you ask how well this works. Well, I'm happy to tell you that today, the best 3 networks on the famous CIFAR-10 dataset, the best 3 networks on the CIFAR-10 dataset are automatically constructed by AutoML. Oh, you have a question? Oh, I see. Same. Well, we use various algorithms for the controller. And one controller would be an RNN to write down the program, and the other controller is the Bayesian optimizer. So we try various controllers. And in this talk, I just described one type of controller. But you can try evolution, you can try random search, and you can try various algorithms. We can talk offline, and I can tell you a technical report to describe the comparison. But for now, just consider all of them are the controller algorithms. Starting with NASNet A, we already beat the state of the art, and now the two best architecture, ImageNet and AutoML, are also much better than human designed. On the ImageNet dataset, this is the holy grail of computer vision. The latest best 3 architectures on this dataset are also automatically generated. So this is basically, every single line here, every single dot in this figure will win you the competition of ImageNet, or winning you a best paper award at a conference. And here's are the latest best 3 generated by AutoML. We now are into the second generation of AutoML for architecture. So in the first generation, I'm showing you, so in this plot, I'm showing you accuracy versus flops. So this is a standard figure that computer vision experts usually measure their models against. Now, the black dots are the frontier curve of human design. Now, you want that curve to be move forward to the top left corner as possible. So higher is better. Now, the first generation of AutoML is the blue dots, the blue curves. So that's started with NASNet, and now it's ImageNet, and etc. And we are into the second generation called EfficientNet, where it's trying to generate architectures not only for accuracy, but also for efficiency. And as you can see, the red curve is much better than human designs. So we, at Google, we apply this technique to Waymo. And you can see the blog post here. We found, the black dot is one model that designed by an expert at Waymo on the self-driving car. And the power of AutoML is not only you generate one model, you can generate many, many models. And we actually, indeed, we generate a frontier curve for Waymo, and they're all better than the human design for different latency and quality trade-off. In that part of the talk, I just mentioned about the architecture. We pick architecture because architecture is a conventional component that many computer vision experts work on. But we also work on data processing and augmentation. So in computer vision, here's a standard technique that people usually do. They have a million images, and then for every image, they generate like a perturbation of the image. You rotate it a little bit, or translate it a little bit, or darken the image a little bit, so that you end up with 10 million images rather than 1 million images. So that's called data augmentation. And we propose something called auto-augment. Namely, the controller will generate not only the architecture, but also the policy so that you can do data augmentation. So it will generate other images that you can use so that you can improve your model. And these policy will be tried and will be given as feedback to the controller so that the controller will learn to generate better policies over time. And again, we beat the state of the art on probably all the data sets that we tried. So this is why we do a lot of research in this area. We realize that a lot of the things that we do have very limited to academic problems. So, and we became interested in the question of how can we scale a lot of our research to many, many unknown problems outside of Google. So we built AutoML as a product. And you probably have heard Cloud AutoML Vision, which was launched last year. That was basically built based on a lot of research that we did. But not only we do architecture search, we actually automate many, many components underneath of the machine learning pipeline. Let me give you an example of how this is being used. So we work with this company called ZSL. It's like a animal protection organization in England, and their goal is to use an algorithm to detect animals, so rare species. And they have cameras, they put it in many places, and then if as some animals appear in the camera, like that's the picture on the right, the algorithm needs to detect whether that's one of the animals that they want to, is it like a rare animal or is it not a rare animal? And when it's a rare animal, what kind of animal that is? The challenge here is the dataset is very large. And it's very difficult for them to manually design the machine learning model. So they're trying to work with a lot of machine learning experts, but the problem is becoming very difficult for them. And so what we want to do is to offer Cloud AutoML Vision such that it requires, you don't need a data scientist to do a lot of training. And it will automate most of the time-consuming work in the image processing, and it will do large-scale experiments very quickly with the TPUs. Our goal is just we build a front end where you can just upload a data set, and it will output a model after a few clicks. Currently, you have to wait for a day or so to get back the model, because if the dataset is large, it takes time to train the algorithm, because the controller needs to try various schemes of processing and model construction. But usually, the quality is extremely high. Here's a processing pipeline. You prepare your dataset and labels. And then you basically upload the dataset to cloud, and then you specify how your model should be evaluated. And then step number 4 is after the architecture and the model is being generated, you can use the trained model for prediction. And we generate an API call so that you can actually, given a new image, it can make a prediction for you easily. Now, we have tried AutoML Vision for many, many customers, and we found that it performs extremely well. And it's, in terms of quality, this is very good. Even some of my friends, they're trying to compete against AutoML Vision, and they find that the solution is very high quality. And the interface will basically essentially just have a data set and specify amount of computations, and then it will basically return a model for you. That's basically what we want to happen. We don't want you to write Keras code like the previous guy anymore. I'm just kidding. If you zoom into the whole pipeline, basically, you have, first of all, it will do automated feature engineering. It will do automated architecture search. It will do automated hyperparameter tuning, model selection, transfer learning, etc., and then export the model. So a lot of people just thought that AutoML is just architecture search. In reality, it's actually many, many components put together just to optimize the quality for you. We actually employ a lot of multitask and transfer learning so that we can optimize for quality, speed, and cost as well. So when you upload a new data set, we actually try to understand how many examples you have and how many features you have, so that and given that we have success in previous data set, we specify a new model construction that looks similar to the previous experience. And for that reason, we can lower the cost very quickly for you. We work again with the ZSL example. The head of the institute is very happy. I think here's a quote that he wrote in a blog post. And he praised AutoML, Cloud AutoML, because it allowed them to focus on their conservation effort rather than doing machine learning, because they don't have a lot of experience doing machine learning. Built on that success, we recently have a lot of requests for people to not only to build a machine learning model on the server, but also build a machine learning model for edge devices like the phones. And we done a lot of research for AutoML for mobile vision, where we say, the same question, can we design a better model than an expert design model for mobile computer vision? And here's the state of the art called MobileNet. So MobileNet basically architectures designed by a team of 10 or 20 experts at Google. They're very good. And amazingly, AutoML was able to actually beat these experts at Google, quite a large margin, as you can see. And the network is called MNASnet. But in the future, if we're gonna open source MobileNet v3 soon, and MobileNet v3 is essentially being generated by AutoML. And based on this research success, we actually launched AutoML for Edge Vision in cloud. Here, you can actually, it will do AutoML for vision, but also consider latency and production ready, like TF Lite support for you. And you can download the model and put it on the phone for your phone apps. We also very surprised about how general our algorithms are. So previously, in the first year or so, first 2 years or so into our project, we just mainly focus on computer vision. But recently, we say, oh, hey, how about we try the same pipeline for structure data, for tables data. So many Kaggle competitions will basically have a lot of table data. And we benchmark our solution on a number of data sets, very famous data set, as you can see here, KDD, Allstate, Mercari, Walmart, Critel, etc. And here we plot the ranking, the percentage of ranking. So basically, higher is better. So 0% meaning that we beat all Kaggle competitors, human competitors. But so lower is worse. So at lower meaning that we lose all this competition against human competitors. And the blue bars are our solution. And then, as you can see, in some data sets, our solution is in the top 10% quantile of competitors in Kaggle. Now, in some data sets, we do not very well. For example, the Porto Seguro safe driver prediction, we actually lower than 50%. But when we benchmark it against other solutions in the market, compared to various other vendors, our solution stand out very well. I think we actually win 4 or 5 out of 6 data sets. So we're very excited about these results, and we also launched, I think today the CEO of Google Cloud has announced AutoML Tables as one of the solution available on cloud. So you can try it out today with this solution. Tomorrow, my team is going to be around and participate in the competition as well. So we see how that goes. You can tell us whether this chart is validated or not. So AutoML Vision and AutoML Tables are 2 solutions among many other AutoML solutions built by my team. So and with the collaboration with cloud. Here I also talk about I can talk about AutoML natural language. So for example, if you upload, if you have a data set where you want to classify text, you can upload it to cloud and it will classify the text for you. Machine translation and video. So today the Google CEO, the Google Cloud CEO also announced AutoML video for beta. If you have a video classification data set and you want to upload it to cloud and classify it, we can do it today too. With that in mind, I want to draw a conclusion to some of our research. So first of all, in the first part of the talk, I mentioned AutoML as a research methodology. So our goal was to achieve higher accuracy and accelerate machine learning research. And I show some of our research results in getting state-of-the-art accuracy on CIFAR-10 ImageNet. And not only automating the architecture design, but also automating data augmentation and data processing. So that's the first part of the talk. The second part of the talk, I kind of try to highlight AutoML as a product. And here, I want to emphasize 2 things. Number one is not only we try to automate only the architecture and data processing, but we also try to automate the entire machine learning pipeline. So that we can make it available for many applications and for everyone. Now, one thing that of a very strong emphasis in a lot of products we build is the emphasis on quality. I think a lot of when you try AutoML by many other vendors, as I also try some of them, and the quality is very low. And at Google, we want the focus to be quality. So if you want to if you want a very high quality solution with very good accuracy, I think you should check out the Google AutoML, Google Cloud AutoML. Now, with that, I'm ready to take more questions. Yes.